And they do have an amazing poster out in the poster session, so please stop by and ask them all kinds of hard questions. I've been asking them hard questions this entire time, and I have yet to stump them, so I hope you can. With that, we'll move on to our next talk, and this is an overview talk for parallel session number 7 on human exploration of the moon and asteroids, and it'll be given by Jeff Plescia on the moon's role in exploration of the solar system. Thanks, Jeff.
No, I know I'm preaching to the choir here, but you know, you heard a little bit from Greg about the global exploration roadmap and what different countries think. The point I wanted to make here is the moon offers a number of opportunities, both for science and technology, in terms of future exploration. And I think you can make a fairly long list, and you can put them into different categories. I mean, one of the things obviously is science. There's lots of lunar science to be done, independent of whether we go anywhere else beyond that. The moon can serve as a test bed for a whole bunch of things, and I'll get into some more details later. The moon can also be used to produce resources for either life support or fuel. These two things are sort of specifically related to the implementation of going somewhere. This is science. And then there's aspects that have to do with public support and national security, getting the public involved, providing commercial opportunities, and issues of national security. The science and these things could all not be there, and this would still be important if you're going to go out beyond the moon or beyond low Earth orbit. I mean, obviously, the premise of all this is that something like the roadmap would actually get implemented. If we're just going to stay in low Earth orbit, then this is all moot. Okay, as you heard, NASA's interested in going to Mars. And I don't want to debate whether this is a good idea or when it should occur, but if this is the plan, this is a fairly long path from here to here. It involves a lot more than just going and bringing a small rock back. The global exploration roadmap looks like this. Basically, there's a whole bunch of destinations. Greg sort of alluded to them: asteroids, going to the moon, staying in lunar environment, and going on to Mars. Okay. We've had a whole number of missions recently that have gone into lunar orbit, and with the Chang'e down to the surface, there's a whole bunch more planned. We've learned a lot in the last sort of 5-6 years about the moon, but there's still a long line of questions that are unanswered. We've been to a lot of different places on the surface, both the U.S. and at the time the Soviets, which are in red. The U.S. are in blue and yellow, which are the Apollo and surveyor sites, and then more recently the Chang'e lander up in northern Mare Imbrium. So we've got a lot of data, but in fact, you know, if you add up the area that has been explored here, it's really a very tiny area. I mean, the half of the landers were static, so they just looked out in the local area. Even the Apollo missions never got very far from the LEM. Okay, so any number of groups have put together long lists of questions. You can pick your favorite question here. There's plenty of stuff to be done in terms of lunar science, looking at the surface, trying to understand how the moon evolved and what's going on there. In addition, as Jack Burns has been arguing for quite a while, there's a way to use the moon as an observatory platform, be it in the visible or radio, and doing it either from the near side or the far side or the poles, depending on what your objective is. But the moon provides an excellent observatory platform to be used as well. Okay, a test bed. This could involve both operations on the surface and in cislunar space, either in lunar orbit or at some Lagrange point or between the Earth and the moon. And it provides a couple of key aspects. It's a deep space environment. You're in a hard vacuum. You've got the thermal conditions associated with both being illuminated by the sun and being in shadow. It's a deep space radiation environment, at least during the part of the lunar orbit when you're not behind the Earth. It's got low gravity. It's higher than or lower than Mars, but it's lower than the Earth. So you're getting some understanding of how things operate in a low gravity regime. It's covered, in the case of the moon, with a fine-grained, very abrasive material. You heard a little bit about that before. This may not be a good analog for Mars. The other thing, though, is its proximity. Okay, if you want to practice being in deep space and doing long-term exposure studies, you sort of want to be able to communicate and, if possible, go fix the problem quickly. You can do that if you're in a lunar orbit with a vehicle. If you're on your way wandering around out to an asteroid or just taking a test flight to Mars and something goes wrong, you've got a problem. You can't really do anything about it. So the moon provides that opportunity. As I said, and everybody knows, going to Mars is a long-term flight. You've got a long way to go. There are not many options to return. I mean, you can not land on Mars and go back around the solar system and land on the Earth, but you've got to have systems that are reliable. And one of the ways to test these things is in a lunar environment. You could actually test the systems. You don't even need a crew. Just put them into lunar orbit, let them sit there and perk away for a couple of years. If something happens, you have the opportunity, because it's so close, to go there and figure out what happened to the vehicle and how to fix the problem. Another issue is ISRU. This is an example of, or a cartoon of what might happen on Mars, where they've prepared fuel from the Martian environment to come home. This is something that needs to be tested. While the chemistry may be different at the Moon than it would be at Mars, understanding how to process the material, how to collect it, how to store it, how to use it, all needs to be demonstrated before you go to Mars and try to do it on your own. Surface ops. We're going to land, if we do land on Mars, you're going to operate on the surface with rovers and stuff, and you want to test the systems out. The big bugaboo has been dust. In the case of the Moon, this is Jack Schmitt, who had a hard time standing up, which is why he's so dirty. And as Rob just showed you, the suits were all covered with dust. This is a different kind of regolith than you would see on Mars, but even so, at the Moon, it would provide you the opportunity of understanding how the seals work, how to keep things closed and not allow dust in, and provide a whole bunch of test opportunities, in addition to all the stuff you're doing at the Moon. In the case of Mars, I mean, perhaps a better analog is this. I mean, this is not really supposed to be funny. This is a C-130 in the Middle East landing, and you can see all the dust that's being generated. This is the kind of problem that's perhaps more analogous to Mars, and understanding how these things operate would be a good analog as well. Okay, people have talked about using humans and robots together. Working with them on the Moon would be an excellent way to figure out when is the human the tool of choice for doing exploration things. You've got robots. There's pros and cons to each of them. They are expendable. They're excellent at boring tasks like listening to me. They can operate in extreme environments, and they can work continuously as long as they have power. But they are power constrained. They're typically slow data rates. You have a limited payload, and they're somewhat expensive. That's not to say that humans are cheap. On the other hand, humans are incredibly adaptable. The good example was the orange soil at Shorty Crater on Apollo 17. Schmitt was walking around and kicked up some stuff and immediately noticed it didn't belong there. Rovers will find stuff if they're asked to look for them, but they won't just notice something out of context. They also can operate in very difficult terrain. Here's Schmitt. I think this is a Camelot crater, but this is boulder field here. Trying to get in and out of this, you wouldn't be able to do this with a rover because you couldn't get access to it, and you'd never have a rover capable probably of getting over these rocks. So the humans have an ability to do things that really are not possible with a rover, but they require life support. They need to eat and sleep and other things, and so there's a much larger infrastructure in their use, and so you want to use them where they really matter. Lunar Resources. This I attributed to Larry Taylor and was told this morning this belongs to Larry Haskins, but Larry was happy to accept the credit. The idea, lunar resources can be used for a lot of things, both life support as well as fuel. And it's the fuel that makes up the most important aspect of using it, because it's the largest mass and it provides the most leverage in terms of reducing the launch costs from the Earth. The key elements are oxygen and hydrogen. They are, in fact, everywhere on the Moon. It's easy to find them on the Maury and the Highlands. No matter where you go, you're going to find these two. Oxygen is typically associated with the rock and it's some sort of silicate, and the hydrogen is either native hydrogen or some sort of OH bound to the surface, and you're going to see that anywhere. However, at the pole, presumably if the various kinds of remote sensing data are correct, there's ice in some significant quantities in the permanently shadowed craters, presumably, and as Matt was saying yesterday, there may be areas outside the permanent shadows that are cold enough to store water, but we don't really understand the real distribution of the ice. It's fairly simple to electrolyze the water into hydrogen and oxygen, and so now you have the two key elements you need for the fuel, as well as for life support. But you really got to define what the resource is. What are you trying to use, and how are you going to extract it? I don't think we have any clue, for example, with respect to polar ice, how we would get it out, how we would move it, how we would work with it, how we would store it. And so you need to, in the case of the Moon, if you're going to use this, pick an ore, figure out how much it's going to cost in terms of all the aspects of the infrastructure to do, and then figure out when it actually becomes economical. And you need to demonstrate it. their experiments are planned for Mars and for the Moon that are small scale things to determine whether in fact you can get some various compounds out of the atmosphere of the regolith. But what you really need to do is demonstrate this in an appropriate scale. If you're going to hang fueling a vehicle to go to Mars or come back from Mars or stay in orbit, you've really got to be able to demonstrate that you can get the material, process it, remove the elements, and store them. And then there's a whole series of transportation. Storing cryogenics for a long time, either on the lunar surface or in lunar orbit, or even at Mars, is going to be a difficult thing. Even if you have them in the tanks, you've got to get them into the vehicle somehow, which requires fueling hoses and all kinds of things. It's a very complicated problem, and you really need to demonstrate it and work out all the kinks before you're trying to do it on the surface of Mars. The other thing it provides, if we had a program where we're actively operating at the Moon, it provides visible milestones to the public. Just like in the Apollo program, we had a series of steps where we launched people into a suborbital trajectory and then into orbital trajectories. Then we went on to multiple people in the vehicle, rendezvous and docking, spacewalks, testing out each of the components that would be needed ultimately for lunar flight. We got actually into testing the hardware first in Earth orbit and in lunar orbit, all of which were visible goals to be met to show that we were actually making progress to the ultimate goal, in this case of landing on the Moon. It also provides public engagement. I mean, for those of you that were alive during the Apollo era, there was a huge amount of public interest in what was going on. People stayed up all night, watched TV all around the world to watch when Aldrin and Armstrong landed on the Moon. And even though the pictures were terrible, everybody was glued to their TV. And ultimately they had ticker tape parades and a lot of fame. But this really kept the public interested in what was going on. It was things to be seen and watch. And so scenes like this I find really are exciting. This is Jack Schmitt next to the boulder at Station 6. Not only can you watch him operate in the environment, but the scenery is great. Just to poke at arm, I find this picture a lot more compelling than this one. I'm sorry. Now, as we all know, NASA's not interested in going to the Moon, and they've done this in multiple languages so their partners know. But in fact, I think the Moon really provides a whole series of opportunities. Even if you don't want to go to Mars, it provides opportunities for learning and living in space. And if you're going to go to Mars, then it provides the test bed you need to do that. Thanks.
We do have several minutes for questions.
Jack.
Jack Burns. Jeff, nice talk, good overview, and I think justification for using the Moon as that stepping stone to Mars. You mentioned robots and humans together, and we often hear this, is it robots or it's humans? The future of exploration and science is robots and humans together, and there's an opportunity to begin that even with the first set of flights with Orion and SLS in cislunar space, particularly with development of a habitat doing teleoperation of assets on the lunar surface. That will begin exercising this human-robot interactions, which I think will continue on the lunar surface when you will have astronauts also teleoperating a series of rovers as they explore together. So we need to move a little bit beyond this idea of the robots versus humans and really be thinking about the synergy between them.
Oh, I didn't mean to imply there was versus.
No, I know you weren't, but I'm saying
Okay.
that's out there, and I think we need to overcome that perception.
I think the key is just to figure out which does the best job at a particular task. And one of the things I remember is Schmitt having to read the gravimeter on Apollo 17, which was interesting data, but a really time-consuming task that a human didn't need to do.
Hey Jeff, Paul Abel, NASA Johnson. So one of the things, a couple things is one, keep in mind we're not going to a very small asteroid anymore. So just understand that graphic, but we're going to a much bigger asteroid. So, the other point I'd like to make, which you touched on, but you didn't go into any detail, is the aspect of national security, and I think that's very interesting. But I'd like to hear your thoughts on how the Moon plays into that role.
I think the U.S. needs to maintain a presence, at least in cislunar space, that doesn't require going to another country to get there, because I think there's in a sort of Apollo-esque way, there's a perspective that if you can't even launch somebody into low Earth orbit, it's not clear how capable you are technically. And I think there's a certain level of waving the flag, if you will, that's important to national security. I'm not talking about, you know, Battlestar Galactica kind of stuff. It's just a presence there to demonstrate your capability, and to make sure that everybody, you know, that other countries don't presume to, you know, take over parts of the moon or space and deny us access to it.
Okay, so it's actually not so much national security as national capability, national prestige.
Yeah, it's all of that together.
Okay.
But I don't mean it in a true military sense.
Okay. Yeah, it would be good maybe to elaborate that for other people, because I think some people take that the wrong way.
Okay.
Yeah.
Actually, I'd just like to follow up on that. I'd like to look at this and emphasize and support your point that it's national pride and prestige. Pride's how we view ourselves, and prestige is how others view us. And I think that's not like aggressive national security. That's just leadership, okay? So, but my question was, I think I'd really like to emphasize what you and Jack were talking about with this human robotic aspect. Really, it's synergism. It's totally synergism. People don't remember that we had over 20 precursor missions before we went to the moon with Apollo. 20 plus, okay? So, you know, that's a lot of information that we got. And it won't happen without that in the future. We have one now, Lunar Reconnaissance Orbiter. And also in the Apollo days, if Apollo had continued, we had developed plans to do, in fact, dual mode rovers, where the rover would be, after the astronauts left the surface, would be sent off for 500-kilometer traverses to the next landing site to get integration and interpolation between landing sites. So there's all sorts of human-robotic partnerships that can really be done effectively, and I just wanted to underline your point. Thanks.
Yeah, I agree.
Yeah, I do think it's critical to go to the moon, but I differ in a lot of what you said about in sutro. There's so many conditions. You would not be using the same equipment, the same design on Mars, especially, and methane is so much easier to store for years than hydrogen. So the best place to mature a habitat would be in LEO, spinning with a counterweight, so that we can learn the health effects of partial gravity. We need to do that right away before we send humans to do much more.
I don't disagree about the station at LEO, or a Lagrange point. I didn't mean to imply that the fuel you would use that you would produce on the moon is the same at Mars. The point is to understand how to go through the process, how to extract a resource, how to store it, how to transfer it. Any more than Gemini docking with an Agena was the same as the LEM docking with the command module in lunar orbit. You're testing different aspects of the process.
We have time for one quick question.
Okay, Margaret Race, I'm with SETI Institute and NASA's Planetary Protection Office. When you want to talk about why it's important to have robot-human teams, when you get to Mars, one of the things you'll have to do is science exploration, and special regions are limited to robotic exploration before humans go into them, or so that it has to be very much a part of what you're doing on the moon to test it. So if you're looking for another piece, planetary protection is also a part of the science.
Thank you.
Thank you.